So at the top here, you're going to see. I'm not sharing, so you're not going to see anything. Give me a minute. Okay. I'm getting the rush, having to run up here from advisory. All right, thank you. So you'll see at the top here, it says, similar to what we just quizzed on, all forms of quadratics. So you're going to see a table, a graph. It's going to ask you about vertex, standard form, how we can factor, all that good stuff. Then you're also going to see what's called a discriminant. And that's kind of what we get in here to here these next couple of days, is this idea of a discriminant. We'll start getting some negative numbers underneath our radical that I've been telling you that you shouldn't be getting. We'll start to introduce those. What does that mean? And that's kind of the last thing that we want to get at with all of these quadratics. So if you look at your notes here, it says using the tables and the graphs below, write the standard form, factored form, and vertex form of all of our quadratic equations. If it doesn't factor, solve by using the quadratic formula to write it in factored form. All right, so that's kind of the key thing here. We in a second. If we can't factor it, so obviously we know some of them can't, so we just quizzed on. We're going to solve it by using the quadratic formula. That's how we're going to do it for factored form. All right. So if we look at this one, see if you remember this. A, what is the vertex of this parabola? We should be able to look at the graph. We should be able to look at the table, and then just write that point down. That should be something that I would hope we are still good with. It's not a great picture for you guys in here, though. Although you have your notes in front of you. All right, and then how do you know? You can, it's up to you. We can look at our graph. You can look at the table. But hopefully our vertex, what is our vertex? I should probably check. What, -2, -1. So hopefully we all get that for our vertex. You can look at your graph. If in terms of your justification here, you could say it's the minimum value on its minimum point on the parabola. It's the lowest point. If we look at our graph, if you want to reference your table, we can look at our table here, and then if you remember, that's the middle because these two values directly in front and behind are the same, and then 2 in front and 2 behind, so on and so forth. So that's how we know that's the middle of our parabola. So there's different routes we could take in terms of how you're going to justify this. All right, either one of those is going to work. I then ask you what your x-intercepts are for the parabola. What we wouldn't want to do on the graph is make any assumptions. So if you look right here, we can look at this. But unless it goes directly through a nice integer where we have these tick marks on our graph, we wouldn't necessarily want to assume that this is a halfway through point. So the way that we would want to make sure of this, the table does work nicely. Because if we come over here, this is one of the questions on your quizzes. Our x-intercepts is when the y value is a 0. So if we look at our table, we're going to see a couple of places where the y values are 0. So our x-intercepts have to be x equals a -3 and then x equals a -1. And we know that for a fact because of the table. So how do we know that? We can just say the y value equals 0 in the table. All right. Okay, so then from there, vertex form. So if you remember what vertex form was, so here's our vertex form. But as long as we knew what the vertex was, which we do, because we did that up here in A, you have it in your table. So here's our vertex up here. So we already know this. We should be able to fill in here and here with the point that we have identified what our vertex was. So since our x-coordinate was a -2, where's my mouse? There we go. Then I can go to H. A little smaller. Yeah, and since my x-coordinate's a -2, I should end up with minus a -2. So that ends up with x plus 2. And then instead of a plus k, since our y-coordinate up here was this -1, we can do a minus a 1. But the issue was always, just let's figure out that a real quick, because it could be 1, could be 2, could be 3, could be 1/2. We always did a little bit of work to make sure that we actually knew what that was. And what we then did is just pick any other point, pick a nice point. So I would say like this is a nice point because there's a 0 here. This is a nice point, and then just substitute in. So I'm going to use this guy because it's the smallest number. There's a 0 there. So let y be a 0. Let your x be a -1. So we get 0 equals -1 plus 1 is a 1 squared minus a 1. This over here. So stay out of this. So we get 0 equals 1 squared is just a 1a minus a 1. Add your 1 over. And what we just see is that our a is a 1. So we come back up here. If this a is a 1, this is our vertex form. Right? Then we want to do factored form. We want to do standard form. I kind of wish we had written this a little bit differently. We actually let's do standard form first because we want it to be in standard form before we start to try to do factored form. But we could use the table. We'll kind of show that here in a minute how we could do this without doing a lot of work. So let's take what vertex form was. And let's simplify this. So remember how this is, if we actually did our little area model, I would have an x plus 2 on top and an x plus 2 on the bottom. So wouldn't that mean we have an x squared, a 2x, a 2x, and a 4 if we just did that? So this has to be x squared plus a 4x plus a 4, and then minus a 1. So our standard form, combine those like terms, x squared plus 4x plus 3. This is our standard form. Now use this to write your factored form. They'll actually show another way that if we can, we could do factored form also. That's a little bit shorter. So now factor this guy, if it does factor. So are there two numbers that multiply to be 3, and at the same time would add up to be a 4? Yeah, we're getting some affirmations there. Not a lot of options, right? The only numbers that multiply to be 3 are 3 and 1. So that's your only options. And when you add them, they do add up to be a 4. So this has to be x plus 1, x plus 3. That's our factored form. All right. Now, let's say we don't want to have to do this first. We actually could have done factored form a little bit easier. So let's go back up to here. Because if we just focus in on actually the points that I have circled right now, let me highlight them. Notice how these are our y values of 0. So if our solution is x equals a -3, and then this solution would be x equals a -1, wouldn't our factored form, wouldn't that have had to have been x plus a 1 in order to produce this -1? And wouldn't this have to be x plus a 3 in order to give us a solution up here of this -3? So if I know x is a -3, well, it's interesting. Looks like a bomb or something. What's going on there? So if I know that x is a -3, then that would tell me that my factor would have had to have been x plus a 3. All right, so we could do factored form that way also very quickly. Okay. All right, so what I want you to also now be aware of, because here's what we're really going to get at. Write this in terms of what our solutions are when it asks for our x-intercepts. So come up here in part C and write this down for me. We have 2, and these are rational numbers. So we have 2 rational solutions. All right, and then actually, let's even put the word, these are all of your number sets you would have dealt with a little bit last year in Math 1, in junior high, when you talked about integers, whole numbers, real numbers, all that good stuff. So we have 2 basically normal numbers, rational numbers that are real numbers. Okay. All right, let's go to the next one. So answer letter A, that we should be able to do. So you can either look at the graph, you can look at your table. We know how to find the vertex using both of those models. And you can either use your graph, just go to the lowest point on this graph, which is right here, and just label that point. Or if you go to your table, find the middle number. This here has to be the middle number because of the symmetry that it has. It's in between 1 and 1, 4 and 4, 9 and 9. So either route, -2, 0 should be your vertex. And again, that's how you're going to know. You can either look at your graph, you can look at your table. We know how to look at either one of those models and find our vertex. At least we should. All right, C. Tell me what you think letter C is. What are the x-intercepts of this parabola? So where does that graph hit the x-axis at? Because again, those are our solutions. If you remember correctly, that's what we called our solutions. That's our zeros. Those are our x-intercepts. All right, Cam, what do you think there, Cam?
Wouldn't it be our vertex if -2 comes 0 because the y value equals 0?
Good. So the only place right now, if we go to our table, where we have a y value of 0 is at this x value. If we go to our graph, doesn't our graph only hit the x-axis one time? So for the first time, really, since we've been doing all of these, every parabola we've done up until this point, that whole quiz, everything we've done, there's always been 2 solutions. So when we say that our x-intercepts are a -2, what I'm going to have you now write down here is what we really only have here now is only one rational solution. And then again, humor me for right now. Also, this is a real number. Whether we remember kind of what real numbers are, pretty much everything you've encountered in your whole life is a real number. It's not something you would have focused on a whole lot up until basically today and tomorrow. So right now, that is what we call a real number. It's a rational number. So we don't always get 2 solutions. In this case, we get 1. And again, it's up to you. You know, how do we know? That's where we cross the x-axis. That's where y equals 0. There's different routes you could take to justify that. All right, so now let's put this in the vertex form. So we know if our x coordinate is in the vertex is this -2, then this should end up being an x plus a 2. And if the y coordinate in our vertex is a 0, then we know we would just put a +0 right here. No, you don't have to put a +0. If you don't write anything behind that, that would also be okay. I'm going to leave the 0 there just so we know that that's the y coordinate. Okay, but you don't necessarily have to do that. Okay, so now, if I ask you to put this into actually, let's do standard form one more time. So let's just take this guy, let's put this into standard form. So it's up to you. Let's do it. There's different routes you could take. You can do x plus 2, x plus 2, and then just do our whole foiling idea. So x times x is x squared. X times 2 is 2x. Then we took the 2 and distributed it. So you get another 2x. This 2 times this 2 is a 4. So what we get here is x squared plus 4x plus a 4. So if you need to do this, this is totally fine. Hopefully we're good enough now to understand. If I had x plus 2, are all those area models that we've been doing and still talk about a little bit. If I have an x plus 2 here and an x plus 2 here, that means I have x squared, 2 x's, and a 4. And then that's how we can get x squared plus 4x plus a 4. All right. Factor this for me then real quick. And then put that up where it says factored form. Right. This should also be nice for everybody, because when you think what 2 numbers multiply to be 4, everybody's immediately going to probably say 2 times 2 first. And does 2 and 2 work? Yeah, they multiply to be 4, they add up to be a 4. So we would write this as x plus 2 times x plus a 2. Think about now if I ask you to solve these. So if I now, you don't necessarily need to change yours. You don't necessarily need to write this down at all. But if I ask you to solve this, remember how we would set this equal to 0? What x value makes this a 0? -2, right? Well, what x value makes this one equal a 0? Wouldn't it also be a -2? So even though we get 1, 2 factors, those factors both produce the same answer. And we would know that because we only touch the x-axis one time. So it would be impossible to get 2 solutions if we're only touching it once, or if our table only gives us 1, 0 on the table. Okay? So that's our factored version. All right, so far we've talked about how we can have 2 nice numbers, so 2 rational solutions, real numbers. We now know we could actually only end up with 1 rational number as a solution. So let's go to number 3. Before we even do this, how many answers should this one have? Just by looking at our graph, how many should we have? Yeah, 2, right? Because we're crossing the x-axis here and then here. If we go to our table, however, do we see any y values in our table with a value of 0? No. That means factoring this is unlikely. It's possible, but that tends to probably mean this one isn't going to factor nicely. Yeah, Cam, you have a question?
Is it going to be between -1 and 0? Like last week, I remember there was a problem that we did.
Yep.
Where it was in between 2 numbers.
Yeah, for 100%, our final answer better be some decimal between a -1 and 0. The other answer better be some decimal between a -3 and -4. And then the question is, what is it? And you're not going to guess. We have our other methods to figure that out. Okay, so just know right away we're going to have 2 real answers. So that's going to go in letter C. So we're going to have 2 answers. We just don't know if they're rational or irrational yet. So we're going to hold off on that. So let's do our vertex. What is that? It's -2, -2. We can also do it from our table. Right here is where that symmetry starts, -1 above it, -1 below it, and then 2 is above, 2 is below. So we can put this in the vertex form. We would do x plus, oh, I guess I didn't tell you what, we didn't solve for a last time. Maybe we should have talked about that. Get on. And then our y coordinate is a -2 also, so we're going to do a -2. We do want to make sure we know what our a is. All right, so we do want to go through that. Last time I just told you that we didn't even go through it. It was a 1, I promise. But we would want to confirm this. I'm going to use this point to figure out what a is because there's a 0 there. And I think is going to make this the easiest. So let y be a 2. And then our x is a 0. So we then get 2 is equal to 2 squared is a 4. So we get 4a minus a 2. So I'm just going to rewrite this over here so you have a little room to operate. We'll add 2 to both sides. And we get 4 equals 4a. And what we get is our a is equal to a 1. All of these have a values of 1 right now. We're not trying to get too tricky with this. So we can now go to that. And we know this has to be 1. All right. Let's put this in the standard form. So take that vertex form. And let's put this into standard form. So that just means we need to multiply this all out. Same one that we've done in the previous 2. So at this point, we should know that's really x squared plus 4x plus a 4. This is the 3rd time today we've done x plus 2 quantity squared. So whether you multiply that out the long way, or we know how to do the little area model, a little shortcut, that's fine. And then we still have this minus 2. Combine linear-like terms. This is the standard form. Take that now and factor that. So now put that into factored form. Okay. And then hopefully with a little bit of number sense here, don't work on this too long, right? There's not a lot of combinations that give you 2, and there's no chance those couple of combinations are going to add up to be a 4. So this doesn't factor. So what I said earlier in those directions we highlighted, for factored form, again, factored form's our first option, is the easiest thing to do. It's quick, it's simple, it's our method we would prefer. If we can't, we've got to do other options. What I told you in the directions, if it doesn't factor, I want you to do the quadratic formula here in order to get what our answers are. All right, so over here, we're going to do our quadratic formula. So a little review here for the first time today. We would want the opposite of b. So our b would be this 4. So that's a negative 4. Plus or minus the square root of b squared, so 4 squared. I'll make this bigger here. You can see. And then minus 4 times a. A has to be the 1, and that's right here. And then our c has to be this, not good, negative 2 that was there that I crossed out. All right, so plug that in, created a mess. We should be able to get through those first few steps pretty well. That quiz went pretty well with the quadratic formula. And then 2 times a, 2 times 1. Anticipate if it didn't factor, which it doesn't factor, that means we're going to get one of those ugly radical answers. It's going to be an irrational number. Since we know it doesn't factor, it's going to be irrational. And in this case, we get a 24 underneath the radical. Simplifying that, we want the 2 numbers that multiply to be 24, with one of them being a perfect square. That would be 4 and 6. And then negative 4 plus or minus. And then this square root of 4 is just a regular old 2. Leave the root 6, divided by 2. If you give me this as your answer, that's fine. This does all reduce though. The 4, 2, and the 2 are all divisible by 2. So if we wanted to reduce that, all those could get reduced by a 2, and then that would be our answer also. Either one of those versions is fine. We do get 2 answers. All right, so I get one answer by treating this as a plus root 6. I get one answer as a negative root 6. So like Cam said, we're not going to plug them in now because I think I've shown this a few times, but guaranteed, if we evaluated these 2, one of the answers is going to be in between a negative 1 and 0 at this point, and the other one's going to be between a negative 3 and a negative 4 if we actually plugged it into our calculator. But what we found our 2x intercepts are, so this is now where you're going to write your answers up here. Our 2x intercepts are the negative 2 plus or minus a 1 root 6. If I can get my eraser. So what we now have are 2 irrational numbers. So we've quizzed on this now a few times. When we have the square root of a non-perfect square, that number is irrational. It's a decimal. You throw that into your calculator. It's never going to terminate. It's never going to repeat. It's irrational. These are still, however, what we would call real numbers. So they're irrational, but they are still what we call a real number. It's an actual decimal that I could plot on a number line. Okay. So what time we got here? 39? Shoot. All right, so real quick, we'll at least get that one started because I want us. The fourth one is the big one. It kind of leads us into what we're going to be doing here for the next day and a half. Here we had 2 rational solutions: -3, -1. Still real numbers. We now know we can have just one solution. This was rational and it's real. We've been doing these for a while. We get 2 solutions. These are what we call irrational numbers because of this ugly root 6, but it's still considered a real number. So if we now go down to number 4, Letter A. The vertex is not a problem. So write down your vertex. That should not be an issue in number 4. What is that? So it should be what? -2, 1, right? And again, you can either use, when it asks you how, we should just look at the lowest point on our parabola or find the middle value right there. Okay, so that's our vertex. Letter C, write down what you think. What's that? Oh, good call. All right, so write down what you think for letter C. What are the x-intercepts here? All right, it's somewhat of a trick question, but it's a really, really easy trick question, right? Like if we're looking at that graph and I'm asking you what your x-intercept is, I'm asking you where does that cross the x-axis? Where does it cross the x-axis at? Nowhere, right? So when it asks what are the x-intercepts of this parabola, there are none. It does not cross the x-axis. That's why over here, you're not going to see any 0 values, right? And aren't all these values positive? So we never even go below the x-axis. We're always above the x-axis. So if I ask you right now how many solutions there are right here, what would we think our answer is if when we cross the x-axis, those are our solutions. If I ask you how many solutions there are in part C, what would we think for our solutions? Yeah, none, right? So here's what I want you to write here. I want you to put there are 0 and then put the word real solutions. There aren't any, right? We don't cross the x-axis. And the x-axis are our solutions. All right, seems simple enough. How do we know? We could put that here. We don't cross the x-axis. All right, at least for the 0 real solutions. So now let's go down to here, vertex form. Hopefully we can at least get to the big part. With that -2 there, that should become an x plus a2 squared. And then our vertex had a y coordinate of a 1. And then it's a +1. I promise you the a is a 1. If we tested it, this a is going to be a 1. So just go ahead, assume I'm right, and put a 1 in front of that. All right, from there, let's go standard form. So I'm going to do y equals, this is now the 4th time today we had, fourth time today I had you simplify that x plus 2 squared. So at this point, we should know that if I'm going to simplify this, that gives me an x squared plus 4x plus a 4. And then I want you to still add that extra 1 at the end. So simplified standard form is x squared plus 4x plus 5. So vertex form, standard form. Factor that now. So go up here, factor that real quick, see if this guy factors. Looks tempting and it looks like maybe this is going to work, but remember they have to multiply to be 5, but add up to be a 4. The only way to multiply to get a 5 is a 1 and a 5, right? Any chance those are going to add up to be a 4? No, so this doesn't factor. So what that means, to everyone's delight, I'm sure, we've got to do a quick little quadratic formula on this. Yeah, Cam?
Wait, can't it factor with the -1 plus 5?
Okay, I would agree that if I add those, that's going to give me the 4. But what's the product of those going to give me?
The product of what? The 4 or the -1 plus 5?
The -1 multiplied by 5.
Oh, it's going to be a negative. It's going to be a -5.
Yeah, we need it to be this +5 here.
Okay.
Okay. So there won't be any way for us to do that. So that means we're gonna do the quadratic formula. Here's our b. B is a 4. So this is gonna be negative 4 plus or minus. And then I want the b squared, so b 4 squared, minus 4 times a. A is the 1 in front of the x squared, multiplied by c. C is the 5 here. All divided by 2 times a, which is a 1. So we get the negative 4, that's leading everything out in front. Underneath the radical now, we're going to get a 16 minus 20. And then all of that goes over a 2. So for the last 3 weeks or so, probably 2 weeks, we've been doing the quadratic formula. I've been telling you we should not be getting any negative numbers underneath that radical. But I said eventually we will. Eventually we will talk about it. We are talking about it now, because if we now look at here, when we see this 16 minus a 20, notice how that is a negative number. It's a negative 4. Divide that by a 2. We're going to end up like 3 minutes short of what I really, you know what, this is actually probably a pretty good place to stop. And then we'll try to explain what that then means, how we handle that moving forward in terms of solutions, so on and so forth. So it's actually probably a pretty good place to stop. But keeping in mind now, we are now all able to get some negative numbers under here. Tomorrow we'll dive into sort of what that means. All right. Okay, that is a wrap. See you guys tomorrow. Have a good night. Stop recording.
No homework.
No homework. The thing we're going to do with the negative underneath is sort of what the homework really is. So we need to hold off on that.
Okay, you guys have a good day.
All right, thanks, Cam. You too. Stop that.